So on your box plot and your normal curve page, I want to connect two things together. Again, the box plot and your normal curve. So let's do these two things together. Let's superimpose a box plot on top of the standard normal curve. So let's first draw ourselves a standard normal curve. I'm kind of drawing mine spread out since it takes I need to have a lot of room with this big fat marker. So, and then of course we have our mean. Okay, so we have our mean. And then how many standard deviations do I have above the mean that contains 99.7% of the data? 3 standard deviations up, and then 3 standard deviations down. Okay, so 99.7 of the data is contained in those. So in essence, how many standard deviations span the entire 99.7% of the data? Good. So there is a total of 6 standard deviations across most, 99.7% of the normal curve. Okay. And so then you know that this is 1, 2, 3 standard deviations up. -1, -2. 1, 2, -3. All right. So what I want to do is put the box plot on top of this. And in a box plot, what were the numbers that were important to us in a box plot? Well, let's start here with min, and then Q1, good, and then median, and Q3, and max. Okay, very good. So those are the data pieces that gave us our 5-number summary. Well, we are not going to address the min and the max because we don't have, that's not identified how far that really actually goes. But we are interested in this section because those can connect to the normal curve. We know that from Q1 to Q3 we have how much data? Okay, good. So we know that our IQR is going to have 50% of the data. Let's think about this normal curve. What do we have on the normal curve from 1 standard deviation up to 1 standard deviation down? How much percent of data? Good. Our empirical rule says that we have 68% of data within 1 standard deviation. Now, here comes the connection. If I have 68% of the data all the way out to 1 standard deviation, then where do you anticipate Q1 and Q3 being in relationship to that 1 standard deviation? A little on the inside. Very good. So I'm going to have it be a little bit on the inside. So there's my box with the Q1 and my Q3. Okay? Now question, where is the median going to be? It will be in the middle. And how do you know that that median is in the middle? Because it's symmetric. Very good. Because we are symmetrical, and so we know our mean and median are the same. Here is our Q1. Here is our Q1. And then here is the Q3. All right. Very good. So, the final thing that connects these two together is trying to figure out exactly how many standard deviations is it to Q3, and how many standard deviations is it to the Q1. So we want to find what value for the Q1 and the Q3. What tells us how many standard deviations up and how many standard deviations down? Very good. That is the z-score. Good. So let's first do that. Let's find the z-score for the Q1. All right. How can we figure that out? Okay, so you say this, don't write this down. Let's keep in mind that we got this going on. Z equals x minus the mean over the standard deviation. Okay, we don't have context here, this equation is going to allow you to kind of connect together context. All right, so we are not doing that equation. So what's our other way to get our z's? Good, inverse norm. So I want to do inverse norm, and what percent of data is below Q1? Good. You remember by definition that Q1 is that place where 25% is below it. So I'm doing inverse norm of 0.25, and if you put that in your calculator, you know that that is negative 0.6745. So in essence, this is about 2/3 of a standard deviation. Why did I say about 2/3? Because 2/3 is how much? 0.6666 repeating. Okay, so this is about 2/3 of a standard deviation down. And that's how you can get your 50%. Okay, so we do need to remember this number. This number will be the standard value. It won't change. And so let's do the z-score for the Q3. All right, how do you want to do that? Okay. Well, if you want to do that with percentages, then we know that 75% of the data is what is below Q3. Well, without even doing that in the calculator, what number is that? Good. Because of the symmetry, it is the positive 0.6745. Okay? And so these z-scores are standardized. They will not change. They will remain that value always for those percentages. Now, I have been asked in my other classes today if you need to memorize this number here. And my answer to that is no. Because honestly, I don't want you to memorize random numbers that you get from a conceptual idea. What I want you to remember from this little exercise here is that Q1 is located at that place where 25% is below it. Okay, and remembering that. And Q3 is located at that z-score where 75% is below it. Okay, so then from that you can get those numbers. All right, very good. So that's the connection between those two, and let's put that into context. So here we go. So John Bill of Stanford, California, recorded the speeds of cars driving past his house where the speed limit read 20 miles per hour. The mean of 100 readings was 23.84 miles per hour with a standard deviation of 3.56 miles per hour. Draw and label a normal model distribution of these readings. All right. So the second concept that I want you to get today, besides those connections of a box plot and a normal curve, is what I want you to include when you make a drawing, a complete full drawing of your normal curve. So here we go. The items that I want you to include in this drawing are your z-scores, your real data, meaning in context, okay? And then I want you to include the empirical rule percentages. What are the empirical rule percentages? 68 is that first one. What's the second? 95, and then the 3 standard deviation, 99.7. Okay, so here we go. Let's draw this normal curve. I'm going to make mine really spread out because I have a lot of numbers to put in here. Leave some space below it, and so leave a space for 2 rows of information below it. Okay, so not beautiful, but there's the mean, and I'm going to go 1, 2, 3 standard deviations up. 1, 2, 3 standard deviations down. And the first thing I want you to include, and so you're labeling over here on the left, is that these are your z-scores. So what's happening is, here is my mean, so put your mu right there. What is the z-score of the mean? Ah, 23.84 is the actual real-world data value. I want the z-score of the mean. It is 0. Because how many standard deviations is the mean away from the mean? 0. Okay. Very good. And then for these values out here, I actually want you to write 1 sigma, 2 sigmas, and this is just to emphasize what this is going on here, what's going on here, and the variables. Okay, 3 sigma, and so then go down 1 sigma, negative 2 sigma, and negative 3 sigma. Now, I want to tell you that 6 sigma, because this spans 6 sigma, correct? You told me that earlier? Okay. 6 sigma is actually a concept that many businesses employ, and engineers for that matter also, because it has to do with the accuracy of production, or the amount that they want to make sure that they encompass and include. And so when we talked about that last year, one of my students said that his mom was currently going through a 6 sigma training, and so I was going to show you the little so when she was done, he gave me the booklet that she was using, and so it was this booklet right here. Apparently this was the business program that they put her through this training, so to learn the 6 sigma. And then Minitab, this Minitab right here is a statistical software that if you get into statistics or you go into a business class that's using that, you'll see Minitab printouts. Okay, and I'll be showing you some of those this year also. Okay, but anyway, so if you are planning on going into business, then you are going to benefit from knowing these concepts that we are doing today with, the idea of the 6 sigma. Okay, so let's move on. Let's put our real data in here. So what is the label for what this real data is about? It's miles per hour. So that's what I'm going to label here. So this real data that I'm about to put here is miles per hour, of which the middle value is how much? Good. So that's where our 23.84 is. And then how am I putting out these other values? Good. Add your standard deviation up. So add your 3.56, and I've already done that for us so that we don't have to waste time doing that. So that's 27.4. Add another standard deviation up. Add another 3.56 and get 30.96. Add another standard deviation up and you get 34.52. And so then going down, what am I going to do? Okay, so my 1 standard deviation down is 20.28. 2 standard deviations down is 16.72, and 3 standard deviations down is 13.16. Okay, so that is the contextual idea, so the context in miles per hour. And so the final thing that I want you to include is the percentages. So that's the empirical rule percentages that I want you to put in. So I would like for you to show an arrow here from 1 standard deviation to -1. And how much percent does that encompass? Good, that's your 68%. All right. How about 2 standard deviations of data? What's that going to encompass? Okay, 95%. Okay, and then how about your 3 standard deviations of data? What's that going to encompass? Okay, good. So that is your 99.7% of data. All right, so those are your percentiles so that you can kind of keep those straight. And then remember, from those we could hash it out and get what's in between and all that good stuff. Very good. So those are the ideas that I want you to make sure that you include when you do a complete thorough label of the normal curve. So let's put this into finding what these actual summary statistics are. The Q1 in miles per hour, and the median in miles per hour, and so on. So let's start with the easiest one. What is the median miles per hour? Good. We know that that's the same as the mean. And yesterday, I was not a stickler on you doing your labels because we were just making sure we had a handle on all that going back and forth between things. But now, I can throw this at you, that if you do not have labels, then the context is not there, and so it's wrong. Because this class is about context. All right, so let's find our Q1. I want to find out what miles per hour it is, at this Q1. So that's my question. How do you think I can figure that out? Good. Good. Very good. So what we're going to do is connect the z-score that we know coordinates with Q1. What is the z-score that coincides with Q1? Very good. Negative 0.6745. Now, we're going to use our little equation. Now we're going to use our equation that turns it into real world data, and that's our little formula thing, the x minus the mean over the standard deviation. So, z equals real world data minus the mean, and I'm plugging in the numbers as I go, over the standard deviation of 3.56. Okay, very good. So then what I'm going to solve that for is my x, and I've already solved that for you so we don't have to go through that algebra. It is 21.44 miles per hour. Okay, let's see if that kind of looks like it makes sense. Does that jive with kind of our little picture we laid out here? Does that look like it could be about 21.44? Yeah, I think so. Okay, so let's find Q3, which is going to be located somewhere about here. Okay, and so we're going to do the same thing. What is our z-score for our Q3? Good, it's the positive 0.6745. So we're going to set that equation up to find the real x. It's a mean of 23.84, standard deviation 3.56, and that Q3 value is 26.24 miles per hour. Forget your labels. So there is our Q3, there is your Q1, which is 26.24. Looks like that could coincide right there with where I did that line. Yeah. And so our final goal for today is to find the IQR. What's the miles per hour span for that middle 50% of data? So how am I doing that? Yeah, take your Q3, subtract your Q1. So I'm taking the 26.24, subtracting the 21.44, and getting 4.8 miles per hour. So about a 5 mile per hour span for the middle 50%. Okay, very good. So what I'm going to have you do the rest of the class is the two problems that are on the back. The two problems on the back do not have you draw out that picture in great detail. However, and then I'm going to have you work on the warm-up also. And you will notice, though, at the bottom of the front page of the warm-up, it is going to be one that you get to practice drawing out, having everything in there. Okay. So I'm going to kind of let you then just get started while I come around and stamp your homework. And I'll come and address this warm-up once more people get to that. So start on that box plot information. Okay, so let's do a little bit of a little bit of guidance in the warm-up here. Okay, so one of the things that they did not do on this problem is put that this table is a reference to hours. Okay, so these are your credit hours, and what they're wanting you to do is transform these hours into your fees, into your money. Okay, so do keep in mind that this is X bar, that is the mean of a sample. See, it's not written with a mu because it's not for the whole population. its x bar is the mean of a sample, and this S is the standard deviation of the sample. So, what you're going to do is take these values here in this table that are the hours and transform them into money. And so you're going to be doing this with a charge of $73 per hour plus the flat fee of $35. So I kind of wrote out an equation to then you would put the hour value in there. So if I'm going to be putting in the mean, then that I'm going to be putting in is the 16.65. Okay, so get in the mind of the person who's writing this problem, and they're trying to see if you know the rule about what affects measures of center and what things affect measures of spread. So if you look at this equation, which has addition and multiplication in it, mean and median are affected by what portions of that equation? Both. Very good. Measures of center are affected by multiplication and addition, so you plug in your values and you follow through with both of those operations. All right. However, standard deviation is a measure of spread, and if you just shift something up 35, the spread does not change. But if I multiply by 73, the spread is changing. Okay? So in summary, with that being said, what of this equation here is going to affect the spread, standard deviation, and the spread IQR? Good, just the multiplication portion, okay? So that was the idea behind this, all right? So I'm going to let you guys work on that. I'm going to come back and help you on the very, very last problem in a minute, after you get to that point and struggle with it for a little bit.